Hello everyone, my name is Leslie and today I will be presenting Group 2's project, which is the electronic deadbolt lock. And our product is designed specifically for elderly individuals and those with physical disabilities who don't have access to traditional locks that require force, any twisting motion, and can be difficult and unsafe to access. Our goal mainly is to create a safer and more accessible user-friendly locking system, which is the electronic deadbolt lock, or EDL for short. So as I mentioned earlier, traditional locking systems can require full mobility and strength, which might not be applicable to our customers. And this ultimately leads to safety risks, loss of independence, and difficulty just getting into your house, your garage, anything that you can apply this product to. So our solution with the product is that it'll be easy of use, very accessible, and it'll be in a key fob, which you can attach to your keys, anything really. So the production process, it implies with 8 workstations, which is the design process, the machining, the woodworking, the spray paint, the electronic assembly, the final assembly, quality assurance, and packaging and shipping. Each workstation will contribute to the overall product assembly. And the takt time so our demand is 50 units per month, and the available time we have in producing our demand of 50 units per month is 160 hours per month. So after you do the math, our overall takt time is 3.2 hours per unit. That's the amount of time we have in each workstation to meet our monthly demand of 50 units. So that means we have roughly about, like I mentioned, 3.2 hours to meet our demand. So in terms of cycle time, the maximal cycle time in each station that we noticed was 3 hours per unit, which met perfectly to our takt time, because the cycle time has to be less than the takt time to meet our demand. So that means that there is absolutely no bottlenecks in our U-shaped cell. And our lean manufacturing approach that we did was to mainly improve efficiency. And those 2 main lean manufacturing principles were just-in-time production, or JIT, and a Kanban system, which will be these cards. It's these 2 cards right here. So there will be 2 circulating in the entire cell system. So we implemented the Kanban system because it is a signal that tells the workstation when to start their production process. So we have, as I said, 2 Kanban cards will circulate the entire production U-cell system, and it'll move upstream from packaging to design. So this ensures that we have a nice pull system and that there's no inventory loss or inventory buildup. And this limits the total work in process inventory, as I said, and ensures a good flow in using line balancing as well. So aka the whole process of Kanban cards is that if a workstation does not receive a Kanban card, they won't start production until they receive that exact Kanban card. And so one more thing to mention is that our project provides a meaningful solution to individuals who have limited mobility, physical disabilities, and it's just very easy to use. Even if you are want this product, you can just easily use it. So from a manufacturing perspective, the system does meet the demand of 50 units a month. The line is balanced, there are no bottlenecks, and our main lean principles are reducing waste and continuously improve efficiency. So that's it. Thank you for your time.
Hello, my name is Andrew Saragosa, and my responsibility in this workstation is research and development and design. What I do in this workstation is to keep up with new Kaizen principles, to always try to upgrade our product while reducing waste and while minimizing size. What we want to do is ensure that we're able to create a small compact locking mechanism in a small package. Here you can see I have a SolidWorks design. This is part of our Kaizen principle of always trying to use new technologies for our application. As you can see here, we have our base to our structure for our lock that we did not end up using for this project because of trying to redo design structures or trying to optimize design or trying to do the same principle with the least amount of resources. Another part of this project is our locking mechanism. We decided to do a remote controller. This was one of the phases that we developed for the user to be able to access the lock, enabled to lock and unlock. If you can see here, one locks our motor and then two unlocks our motor. So within the research and development part of this design, we noticed that after programming and after setting up this type of configuration, that it wasn't adequate for our project development so that we could implement into our project. So we had to get away from this. This total station time was 3 hours. We know that our takt time is 3.2. Our cycle time is 3 hours. The majority of that time comes from group meetings, group discussions, and then overall team collaborative of where we want the direction of our project to go. The majority of our time comes from getting inputs from everybody and then getting all that information, then trying to digest it and trying to come up with a product, something like this or something like this on SolidWorks. And that is the main purpose of research and development and design.
My name is Alfonso Rodriguez, and I'm in charge of workstation 2. And my station is basically just machining, and I am in charge of the metal casing. The 3 processes that we did would be the table shear, the MIG welding process, and also the drill press. It will be the drill press as well. So for the dimensions of the metal casing will be 13 by 6, and then for the shearing on the top and bottom plates, it will be 13 by 3. And then for the sides, we also had it for 6 by 3 inches, and then for the top, the wood piece would be 13 by 3. All right, and then for the welding process, we did a technique called tack weld, and for each tack weld, we had 3 on the long sides, top and bottom, and then 4 on the shorter sides. And then we also had an additional 2 tacks for the brackets right here. And then for the drill press, we had a total of 6 holes. It will be for the mounting and the brackets, and also the plate on this side too. Our takt time was 3.2 hours, and then our cycle time was 3 hours.
Hello everyone, I'm Leslie Zavala and I was in charge of the Word Working Station or Workstation 3. So once I received the Kanban card from the previous workstation, I measured the sizing of the casing, which was this top part, and the measurements were 13 by 3. And this measurement for the mount of the whole entire lock mechanism was 13 by 6. So after I got the birch wood and I properly cut it to its sizing on the bandsaw, I double checked everything to see if it all fit in on top of the steel metal casing. And I also cut these proportion sizes to fit as a demonstration to our customers on how to mount the outer part of the lock. And like I said, after everything was measured, I put everything together. I had this measured and cut as well. This was 13 by 6. I don't know if I mentioned that already, but yeah, after that I glued this on top and everything fit perfectly.
Hello everyone, my name is Al Sadiq. I'm in charge of the painting station, also workstation 4. So after receiving the steel casting, I had to file it down thoroughly to make sure it was a smooth surface. After that part, I got the flat black paint to spray on top of the wood and the steel casing. Also making sure that I don't leave any painting drips, and getting all the sides and everything thoroughly. Once that was done, I had to let it dry for about 3 hours. So once everything was done, our cycle time was about 3 hours. So the tag time was 3.2 hours. So we were well within the capacity of our time. Thank you.
My name is Andrew Romero, and I'm in charge of electronic wire assembly. So once I get the Kanban card, they hand me the wood piece and then the cover. That way, when I put the wiring together in this wireless receiver and attach two 9-volt batteries onto a DC motor, and with the screw, I make sure the height for each individual component can fit perfectly inside. So once that's all complete, after reading the diagram for the DC motor to make sure if the buttons work completely, you go forward and backwards. And then once everything's already completely mounted and also taped onto the wooden surface, and this will get passed on to the next workstation with the Kanban. So the takt time for the electronic wire assembly was 3.2 hours per unit, and then for the cycle time, it's going to be 3 hours per unit. Once I receive the Kanban card for the final assembly, I get the full casing and then all the electronic assembly onto the wooden board to make sure everything fits flush and ready to go inside. And then therefore you use this steel plate to cover the backing. And we use 2 screws to go inside. And then just to double check that everything's flush inside, you take a quick test. Like everything goes through and also comes out. And then once it's done, it moves on to quality assurance. And the takt time for this final assembly is 3.2 hours per unit, and cycle time is 2.5 hours per unit.
Soria, workstation 7, I'm doing quality assurance, and my cycle time is 2 hours and my takt time is 3.2 hours. After I receive my Kanban card, I'm quality and assurance, and I'm making sure everything's smooth and running as intended. Making sure everything's safe, the wiring is right, the batteries are functioning to the motor, the lock is going in and out as it's supposed to, and everything is smooth, and the response time for the control is as intended. Hello, my name is Eduardo Soria. After receiving the Kanban card, I'm going to be sending the second Kanban card to Workstation 1. My station is packaging and shipping. The takt time is 3.2 hours and cycle time is 2.5 hours. During packaging and shipping, I'm going to be including the owner's manual, the instructions, the shipping, where it's going to be shipped to. I'm going to seal this in the packaging with the saran wrap. We're wrapping the project in saran wrap to keep it safe and preventing damages from occurring during shipping.